Good morning, students.
Good morning, sir.
So yesterday we studied about the vapor compression cycle. So we taught about what are the components inside the system that comprises the vapor compression cycle, and what is the use of the compressor, what is the use of the condenser and other parts inside the vapor compression cycle. So you must know that every system that we use in our domestic lives runs on this very cycle, this vapor compression cycle. So basically, here we have a refrigerator, and this also works on the same principle known as vapor compression cycle. The vapor compression cycle comprises of the following parts, that is compressor, and I have drawn here the block diagram for you, and it shows how the refrigerant flows from what system to another, from which part it goes and what is the direction of the refrigerant flow. And we should also know what is the phase of the refrigerant before coming into a component of a refrigeration system and afterwards. Okay, here we have a compressor here, and it is a simple flow or block diagram, or you can say block diagram. You can check how the refrigerant flow takes place. So firstly we have a compressor here. What it does work on the system, increases the pressure, and eventually it increases the temperature and pressure of the refrigerant. Afterwards we feed the same refrigerant to the condenser. From this very part the heat is rejected to the surroundings. Okay, and afterwards we have another accessory part. We have not discussed the receiver yesterday. So here we are mainly concerned with the refrigeration systems now. Yesterday we were talking about the vapor compression cycle, and today we are mainly concerned with the devices. Okay. Yesterday we taught about what are the cycle for the refrigeration. Today we are going to learn about the refrigeration equipment. It can be a refrigerator. So that's why the receiver was not mentioned yesterday, because we were speaking about the general cycle. The receiver was not important to mention yesterday. So today I have installed the receiver in it. I will tell you what is the main function of the receiver and why it is installed in the system. And afterwards we have another device installed in the system. It's called a filter or dryer. Afterwards, then the refrigerant is fed to the expansion valve and then evaporated again to the compressor. Okay. So the compressor is the heart of the refrigeration system. Like we have a human body has a heart. What is the function of heart? To pump the blood throughout the body. Okay, and it is main organ of a body that supplies to each and every part of the body. It has arteries and veins. From one side it gets oxygenated blood, and on the another side it supplies the from one side it gets deoxygenated blood, and from other side it supplies the oxygenated blood to the other parts. It brings the deoxygenated blood and supplies oxygenated blood. Similarly, the compressor of the system does the same work for us. It sucks the low pressure refrigerant from the whole system and discharges the same refrigerant after increasing its pressure to the rest of the system. So we have two pressure systems inside a refrigeration system. One is called the high pressure side and another is called the low pressure side. So there are two different pressures in the cycle. The whole cycle comprises of two pressures. One is high pressure side and another is low pressure side. In some parts the pressure inside the refrigerant tubes and parts is high, and in other parts the pressure of the refrigerant is very low. Okay, you are familiar with these terms, the pressure and what is it. Okay, so the compressor can be of multiple types, but in a refrigeration system that are employed domestically, whether it is an deep freezer or this refrigerator, single door or double door, we have a special type of compressor installed in these type of equipments. That's called the hermetically sealed compressor. What is it called? Hermetically sealed compressor. What is it? It is the combination of two things. It is
Combination
of, it is not a single unit, it is not just a compressor. It has two parts installed in it. It has on the same shaft, the crankshaft of the compressor and the shaft of the motor are directly connected to each other. It means whenever the motor runs, the crankshaft of the compressor eventually also rotates with the same RPM. Okay. Suppose we have the shaft of a motor. You know what is shaft? Shaft is what rotates inside the motor. This is called shaft. It rotates by means of magnetic field and whatever it is. It has the circular motion, a shaft, a rod that rotates. Okay. From what source the power comes from? It comes from electricity, from a motor. Okay. And the same thing is connected to the crankshaft. Okay, whenever this shaft rotates, it is directly connected to the crankshaft. Eventually, the crankshaft also rotates. Okay, and it has the crankshaft has installed pistons on it. Whether it may be single cylinder piston, single cylinder or double cylinder, and the capacity of the compressor depends upon the size and number of pistons inside the compressor. Okay, whenever the number of pistons is increased, the pressure handled by the compressor also increases. So capacity of the compressor also increases by the number of pistons it have and what is the size of the piston. So it does the both parts, and it has another parts like valves inside installed in it. So this type of compressor that we are seeing inside our refrigerator is the simplest kind of compressor. Simple kind of compressor. It is completely sealed. It has not any. It cannot be opened. Its lid cannot be opened. Okay. It is completely sealed. It has only three openings. One is discharge one, and another is suction, and one is for the refrigerant charging. There are three connections to it. Whenever the compressor is damaged or somewhat due to the high voltage, it cannot be repaired manually unless its weld is not broken off. Okay, we have to destroy its joints, we have to remove its welding, afterwards we can repair its motor. So it is impossible for this kind of, I'll show you. This is a type of compressor. Okay, this is a type of compressor I'm showing you here. This is a type of hermetically sealed compressor. Okay, this is hermetically sealed. It has three openings. One is this one. It is suction. Okay. Somebody come here and we will show it. Hold it like this. So this is a hermetically sealed compressor. It has three openings like this. It has three openings. One is this side, and there are another two from this side. Okay. One is for suction, another is for discharge, and another one is for refrigerant charge. So this is the heart of the refrigeration system, or a refrigerant is the heart. It supplies, it sucks like heart sucks blood and pumps it from another side. Similarly, it sucks the refrigerant from one side and discharge on another side at high pressure and temperature. Okay, so this is called the hermetically, because it has the dome shaped top and it is completely welded, so no leakage is possible from this side. Okay, it cannot be. If the motor inside this is destroyed, we have to remove this welding, and afterwards the motor can be repaired. And it is not done. It is done inside the factories. A local technician cannot repair this. Okay, whenever it is damaged. If it is damaged, the better option is to bring a new one. It can be repaired further on, but it takes very good time to repair this. Okay, so better option is to replace it whenever it is damaged. So you have to be firstly sure if it is damaged or not. There are techniques to check how we can say this is damaged or not. Okay, you can sit down. So this is a compressor of the refrigeration system, and especially this is called there are many other different kinds of compressors as well. It can be some compressors are top. They may be screw compressors, scroll compressors. This one is reciprocating compressor. There are another centrifugal compressor, there are lots and hundreds of types of compressors used for different kind of jobs, different kind of machines, different type of compressors are used. But mainly these ones are used for our domestic refrigerators, air conditioners, or deep freezers, visible coolers, etc. Or maybe the display cabinets inside the bakery shops also employ these kind of compressors. So you have understood what is its job and where it is installed. It only and the refrigeration after the compression. After the compression, what is our output? The output is the high pressure vapor refrigerant. But it is not always necessary that the output from the compressor is at the saturated state. It is not necessary. So the refrigeration cycle also, there are types of type of refrigeration methods we are using on the basis of what output we are getting from outside the compressor. It can be at the superheated state, it can be at saturated state, and it can be also at the mixed state. Okay, what is it exactly called? It is called, one is called dry saturated, and secondly is called dry saturated. Another one is called super saturated. Okay, I will tell you later what is it. Afterwards, the compressor necessarily connected to the condenser. The condenser is somebody bring me the condenser here. Oh, this one is installed inside this table. This, can you bring me that? So look here. So another device is condenser. Condenser is connected directly afterwards. So here I will show you the simplest condenser. This is the type of condenser that is used in most of the single door refrigerators. Okay, what is this called? Condenser. This is called condenser. And this is highly coiled. This is highly coiled. This has many turns. And another, we have these things connected to it, welded. These are called its fins. And what are these are used for? To increase the surface area to spread the heat throughout. They are, whenever this heat gets heat up, these fins also get heated. And the heat transfer rate increases by using these type of fins. Okay, so it helps to cool down the refrigerant quickly. Okay, so this is called condenser. It has condenser. The right after the compressor gives the high temperature, high pressure refrigerant that is directly fed into the this side. Okay, this side, top side. Okay, so this is called the condenser. And this condenser is not only this side, there are many hundreds type of condensers that are used inside the refrigerator. Okay, sometimes a fan is installed behind this to increase the efficiency to cool it down very quickly. Okay, so sometimes are air cooled condensers, sometimes it is fed inside the water. It is completely submerged inside the water to effectively reject the heat from this. Sometimes its temperature gets increased about hundreds of degrees of Celsius. In refrigerators, we don't get that much high temperature, but in higher machines, in bigger machines, the condenser temperature could go above 100 degrees Celsius. Okay, so to cool these type of systems, we have to install more efficient condensers that may be water cooled, air cooled, coolant cooled, many types of could be there. Okay. Afterwards, we have another device installed, and it is these receivers are mainly installed inside the modern refrigerators and air conditioners. Okay, and what is this receiver? It accumulates the refrigerant. Whenever the condenser condenses after the condensation, the refrigerant is converted into the liquid state. The job of the condenser is to condense the refrigerant to the liquid state. Condensation itself means bringing it to the liquid state.
Yes, sir.
It doesn't have any effect on the pressure. It just converts into the liquid. It doesn't. And also it brings it near it brings in near the critical state, saturated state. Okay, I have discussed it yesterday. What is the saturated critical state? Okay, and afterward we have another device called filter and dryer. Filter and dryer. Filter and dryer, it is simple device. It has some silica granules in it and kind of a sieve inside, so like जाली. एक जाली होती है और उसमें थोड़ी सी सिलिका पार्टिकल्स होते हैं. वो क्या करते हैं, वो मॉइस्चर को रिटेन, थोड़ा अगर मे बी कहीं से कोई मॉइस्चर आया होगा सिस्टम में, इट एब्जॉर्ब्स दैट. जो जूतों में वो नहीं होते हैं, नए जूते खरीदते हैं उनमें वो एक पुड़िया आती है छोटी सी, उनमें वो सिलिका ग्रेन्यूल्स जैसे होते हैं. वैसे वाले ग्रेन्यूल्स इस फिल्टर ड्रायर में होते हैं. अगर कोई मॉइस्चर इस सिस्टम में आया होगा, इट एब्जॉर्ब इट, इट डजंट अलो दैट मॉइस्चर टू गो इनसाइड द एक्सपेंशन, बिकॉज़ इफ द मॉइस्चर गोस इनसाइड द एक्सपेंशन valve, it may get freeze. That water droplet may get freeze and it may block the, because after the expansion the temperature gets drastically decreased. It may be go below 25 degrees Celsius, minus 25 degrees Celsius. So that water droplet may solidify and it may block the system, it may choke the refrigerant. So when the refrigerant is choked, it may blast. So filter dryer is very important device that must be installed inside a refrigerator and air conditioner. It is installed whenever we charge the refrigerant inside the refrigerant, always we install a new filter dryer. So it is convention. So afterwards we have the device that's called expansion valve. The expansion valve increases the pressure, I have already discussed. And the expansion valve is not also of single type, it is also of many types. It may be a simple capillary tube that is highly coiled and very thin in diameter but very large in length. It may, for a refrigerator, it may be up to 15 feet. The length of the capillary may be up to 15 feet. But we have where it is installed in this machine as well. The capillary is highly coiled. Its length may extend up to 15 meters inside a refrigerator or a air conditioner. Okay, but the capillary is used mainly for the small systems. In larger systems, the capillary is not used, because it has limited capacity and it has not the feedback mechanism. I will tell you what is the feedback mechanism. And what another function of the receiver is that it supplies the refrigerant according to demand of the refrigerant. कभी कभार हमें कम ही रेफ्रिजरेशन करनी पड़ती है, तो उस टाइम हमें कम ही रेफ्रिजरेंट चाहिए होता है. सो ये जो रिसीवर होता है, ये पहले अपनी रेफ्रिजरेंट, लिक्विड रेफ्रिजरेंट को स्टोर करके रखता है. फिर जितनी आगे हमारी इवापोरेटर में रेफ्रिजरेंट की डिमांड होती है, फिर इस रिसीवर से उतना ही निकलता है रेफ्रिजरेंट. ओके, समटाइम्स यहाँ पे बहुत सारी गर्म चीजें रखी हैं तो बहुत सारी हीट ले जानी पड़ेगी, तो सप्लाई ऑफ रेफ्रिजरेंट मस्ट बी ग्रेटर, सो इट सप्लाइज द हायर अमाउंट ऑफ रेफ्रिजरेंट. इट इज लाइक a tank, refrigerant tank. It stores the refrigerant and it supplies according to the requirement. ठीक है. The expansion valve can be of the electromagnetic type, it may be sensory type, it may be any screw type. Here we have expansion valve, is simple thermostatic expansion. It senses the temperature and expands the refrigerant as per need from the feedback from the evaporator. Okay, इसको evaporator ही मैसेज देता है कि तुम्हें कितना एक्सपैंड होना है, तुम्हें रेफ्रिजरेंट को कितना ठंडा करना है. वो उसको इसका जो सेंसर लगा रहता है वो डायरेक्टली कनेक्टेड रहता है इवापोरेटर के साथ. अगर टेम्परेचर बहुत ही ज्यादा कम है, टेम्परेचर अटेन हो गया है, तो रेफ्रिजरेंट की सप्लाई उसको बोलेगा कम ही एक्सपैंड करो, तुम्हें ज्यादा एक्सपैंड होने की जरूरत नहीं है, क्योंकि फ्रिज का टेम्परेचर जितना डिजायर्ड हमें था उतना आ चुका है. फिर उसको हायर अमाउंट ऑफ एक्सपेंशन करने की कोई जरूरत, फिर कम ही. वो चीज किससे होती है, इस जो थर्मोस्टेटिक एक्सपेंशन वाल्व है, ये भी एक एक्सपेंशन डिवाइस ही है, लेकिन ये फीडबैक से काम करता है. इनपुट इसको कितना एक्सपेंड होता है वो इंफॉर्मेशन ये सेंसर के थ्रू इवापोरेटर से लेता है, मैं कितना रेफ्रिजरेंट फीड करना है मुझे. ठीक है, तो दैट इज डन बाय यूजिंग द थर्मोस्टेटिक एक्सपेंशन वाल्व. आफ्टरवर्ड्स, when the expansion has took place, the refrigerant temperature has been drastically decreased and that is directly fed to the evaporator. Evaporator is a chamber where we keep our things cool. Maybe for a bigger system it can be a cold storeroom. Its capacity is hundreds of cubic meters. Okay, it can be like this room big. The evaporator could be this room if the system is big. So this evaporator is the place where we keep our things to maintain their temperature, to keep them below the atmospheric temperature. So this is the part where the things are kept. It can be a cold storeroom, it can be your freezer cabinet, it could be your room that is to be air conditioned. This evaporator could be also a room. It is actually the space that is to be cooled. The evaporator is the space that is to be cooled, and this is the part where the heat gets absorbed, and the evaporator absorbs the latent heat of vaporization from the elements that are to be cooled. Suppose if we have the apples there, or we have, in case of cold store, in case of a room, we have the occupants inside the room, or machines are installed that are to be, if it is a supercomputer room, it can be the processors that are inside on the evaporator. Okay, there are the multiple uses of this evaporator, and the supply of refrigerant is according to the need. Okay, so this is the evaporator, and it absorbs the latent heat of vaporization from the substance, and eventually the refrigerant gets evaporated, and that is fed back to the compressor. Okay, and you must know the pressure after the compressor is always high, and that one is called the high pressure side of the system. Because after the compressor, the pressure is always high. So inside the condenser, pressure is still high. Inside the receiver, pressure is still high. Inside the filter dryer, the pressure is still high. Until this point, and from this point. And this side is called a high pressure side. Okay. This system is called
high pressure.
HPS. I will write down in short form. This is called high pressure. If we install any pressure gauge inside this system, this should show high temperature. And these parts before this expansion valve is called low pressure side. So there are two different pressures inside the refrigeration system. And one is called high pressure side, and another is called the low pressure side. So there are two different pressure systems occurring inside the refrigeration system. So another thing I want to mention here, the coefficient of performance of a refrigerant depends upon the state of the refrigerant that is coming outside from the compressor. Sometimes it may be dry saturated after the compression. The refrigerant will be dry saturated. It means it has no vapor inside it. Dry saturated means after the compression the refrigerant is always in the dry state. Dry state means it has no liquid in it. That is one type. Another one is called the refrigerant is wet after the completion of. It means wet means after the compression there are still liquid particles inside the refrigerant. After compression the refrigerant should be liquid form. Should be gaseous form. But sometimes it is completely dry. It is completely dry. Sometimes it is wet. It means the refrigerant has still some liquid particles. That's called liquid wet saturated refrigerant. Sometimes the refrigerant could be super saturated, superheated vapor. Superheated vapor. It means the refrigerant is at very high temperature after the completion of the refrigeration. So, in order to get a greater coefficient of performance from the refrigerant, to increase the efficiency of the refrigerant, we should always go for the higher temperature after the completion of the compression. जितना आप liquid यहाँ compression के बाद इसकी state liquid में ही रही, उतनी उसका coefficient of performance कम रहेगा. अगर जितना compression के बाद हमारा refrigerant heated होगा, उतना हमारे refrigerant की coefficient of performance अच्छी रहेगी. क्योंकि उससे हमारा हीट ट्रांसफर आगे कंडेंसर में जाके इजी होगा. ठीक है. So the coefficient of performance depends on the state of the refrigerant coming outside from the compressor. So there are three types. One is dry saturated, wet saturated, and super saturated. ठीक है. The coefficient of performance depends on these things. And I can show these things graphically as well. There are different type of techniques that are used that are used to check how our efficiency of a refrigeration system has effect from these temperatures, the temperature of the compressor, the temperature of the condenser. These are very essential for calculating the coefficient of performance and efficiency of the engine. The temperature of the condenser, compressor, evaporator, expansion mode. These temperatures are very critical. These temperatures are very critical in order to know what is the efficiency of the system. So we have to, whenever we are designing the system, these temperatures and pressures are to be noted and checked for how the system is going and how efficient it is. So these temperatures are very important to know and what pressures we are operating. So there are different plots we can check its efficiency. There are TS diagrams, temperature, entropy diagrams, pressure volume diagrams, enthalpy entropy diagrams. There are different type of plots, different type of graphs by which we can check the states of the system and the changes inside, the change happening when the cycle is taking place. We have the graphs help, these graphs help us to understand this cycle very well. Okay, that's all for today.
Thank you, sir.